Hi students, in this video I'll be going through the 2015 Additional Mathematics paper 1 question 11. Alright, so let's read the question. So the diagram shows the vertical cross section PQRS of an open trough made from plastic sheeting. Right, the lengths of PQ, QR and RS are 20, 30 and 20 respectively. The trough rests with QR on horizontal ground and both PQ and RS are inclined angle theta radians to the ground. Okay, show that the area A cm square of the cross section PQRS is given by A equals to 600 sine theta plus 200 sine 2 theta. Okay, so basically what they want us to do is to find the area of this particular shape over here and then show that it's of the form that they indicated, alright? Okay, so over here, this trough is actually a trapezium, correct? Okay, so what we can do is that we can divide it into two triangles and one rectangle so that we can find the area more easily. Okay, so the two triangles will be, one of them will be over here. Okay, so you drop a vertical directly down from a point above Q. Okay, so let's call this point X. Okay, and you do the same thing for a point above R. Okay, drop a vertical down. Okay, so let's call this point Y, right? Okay, then over here, if I extend this horizontal, okay, let's call this Z, alright? Okay, so basically, right now we have two right angle triangles, one on the left, one on the right. Okay, so if we have a right angle triangle and want to find the area, then if we know the length of the base, okay, so for example, now if PX is the base and XQ is the height, then we will be able to find the area, right, through half times base times height. Yeah, of course, for a rectangle, if we know QX, then we multiply by 30, then we should be able to get the area of the rectangle. Okay, then all we need to do is to add up the three areas, and then we should be able to find A already. Okay, so let's go about trying to find PX and QX, the base of the triangle as well as the height of the triangle. Okay, so over here, inside this triangle, we only know a 90 degree, but do we know any other angles inside the triangle? Okay, so you should be able to see that we can have alternate angles with angle PQZ, right? Okay, so angle XPQ and PQZ are alternate angles, so this will be angle theta, right? So let's go ahead and find that. Okay, so let's write that down first. So angle XPQ will be equals to angle PQZ, which will be equals to theta radians, right? Okay, then from here, since we have a right angle triangle, we will be able to use a trigo ratio to find PX and QX in terms of theta. Okay, so let's find PX first. Okay, so if the angle that we are interested in is angle XPQ for this particular question, then PX will be the adjacent side, okay, A, and then XQ will be the opposite side. Then of course the 20 will be the hypotenuse, right? Okay, so since we are finding PX the adjacent side, and we know the hypotenuse to be 20, so the trigo ratio that involves A and H, adjacent and hypotenuse, is cosine. Okay, so we will write down cosine theta will be equals to Px over 20. So Px will be equals to 20 cosine theta, right? Okay, so we can do likewise to find xq, okay, the opposite side. So sine theta equals to xq over 20. So xq equals to 20 sine theta. Right, so now that we have found the px and xq, then we can go and find the area of the triangles as well as the area of the rectangle already. Okay, so let's write the working over at this side. So the total area will be the area of rectangle, okay, of the rectangle XQRY plus area of triangle PQX plus area of triangle SRY, okay, SRY. Right, so area of triangle of the rectangle XQRY will be QX times 30, okay, so 30 times QX, so 30 times QX will be 20 sine theta, okay, 20 sine theta, plus the two triangles, okay, both the triangles are the same, okay, they are congruent, okay, so we can just write 2 times half times base, okay, base will be PX, right? Okay, 20 cosine theta, okay, times 20 sine theta. Right, so from here, this is where we will get the 600 sine theta. So 600 sine theta plus, okay, 2 times half will give me 1. So 20 times 20 will be 400 sine theta for sine theta, right? Okay, so we're almost there. We have this one. Okay, so how do we end up with 200 sine 2 theta? Okay, so this is when the double angle formula will come to mind, right? Because sine 2 theta is 2 sine theta cosine theta, right? So that's where we will apply the double angle formula. Okay, so 400, okay, we can write as 200 times 2 sine theta cosine theta. Okay, so since we want to involve the double angle formula, so I try to bring this 2 sine theta cosine theta into the question now, okay? Okay, so we just have to substitute it there and then we'll get the answer already. Okay, so it'll be 200. Okay, 2 sine theta cosine theta as mentioned, double angle formula for sine will become sine 2 theta. Okay, so we have shown the expression already. Right, so it's not too difficult. Okay, so for this kind of question, just think about how you can find the area. Okay, by dividing up the figure, and then how you can involve the angle theta. So it's often via trigo ratio lah. Okay, for questions such as this, right? Okay, let's look at part B of the question. Right, so in part B, they say that the angle theta can vary. Okay, so if they change the angle theta, that means the angle at which the two sides of the trough are inclined, right? Then they will be able to get different areas for the trough. Okay, so they want the value of theta for which the trough can hold the maximum amount of water. Okay, so remember this trough is like a prism. Okay, so the shape is like this. Okay, it's like a prism. Okay, so it's a prism. When you draw, so this is a cross-sectional area only. Okay, so the A that we have is just this area over here, but the shape of the trough is a prism. Okay, so now they want a maximum volume, right? So to get the maximum volume over here, okay, we will need to have the maximum area, okay, multiplied by this length. Okay, so this length of the trough is fixed, okay, it's a fixed length. Okay, so to get the maximum area, we want the angle theta, okay, you can change. We want it such that you can get the maximum area so that the volume will also be subsequently maximum, right? Okay, so the A we have is this. So it's 600 sine theta plus 200 sine 2 theta. Okay, so if we want the maximum area now, then we know that maximum point for A, the theta is going to be equals to 0. Okay, so let's go ahead and try to differentiate A with respect to theta. So the theta. Okay, 600 differentiating sine will give us cosine theta. Okay, so differentiating sine 2 theta, okay, it's going to give us cosine 2 theta. Okay, then we differentiate the angle 2 theta, we get 2 and we put it here. Okay, so it's going to become 600 cosine theta plus 400 cosine 2 theta. Right, so this is dA d theta. Okay, at stationary A, okay, dA over d theta is going to be equals to 0, right? Okay, so we're going to equate this one to 0. Okay, then let's simplify the numbers first. 600, 400. Okay, we can divide throughout by 200. Okay, so let's make the number smaller first. Okay, so you'll get 2 cosine 2 theta equals 0. Okay, so over here you have a trigo equation whereby there's a double angle as well as a single angle. Okay, so ask yourself one question: what can we do to proceed forward? If I want to solve this equation, right, I cannot be having a trigo ratio with double angle and single angle formula together. Okay, but you should be aware that we can always convert the double angle to single angle, right? Okay, using the double angle formula for cosine 2 theta. Okay, so cosine 2 theta, there's actually three forms, right? So the first one is cosine square theta minus sine square theta. The second form is 2 cosine square theta minus 1. The third form is 1 minus 2 sine square theta. Okay, so which form will you want to put in? 1, 2, or 3? Okay, you have got to decide. Okay, how to decide? You look at the term here. Okay, what term do we have? We have a cosine theta, right? So to solve a trigo equation, remember this. We always want the trigo equation to have just one type of trigo ratio. So in this case, it's cosine theta, right? Okay, so the one that we choose should be number 2, because number 2 also got cosine theta only. So by putting in number 2, the whole equation will just have one type of trigo ratio, which is cosine theta. Right, so do keep this in mind while solving trigo equation. Okay, so you have 3 cosine theta plus 2 cosine square theta minus 1 equals to 0. Okay, so 3 cosine theta plus 4 cosine square theta minus 2 equal to 0. Okay, so over here, let's rearrange a bit. Okay, to make it look like a quadratic equation. Okay, so now it's actually a quadratic equation in terms of cosine theta. Okay, but let's introduce a substitution to make it more familiar to us. Okay, so let y equals to cosine theta. So we'll end up with 4y squared plus 3y minus 2 equal to 0. Okay, if you try to factorize, okay, if you try to factorize this, you realize you can't factorize. Okay, but don't worry, just check your working and see whether you made any mistake. But if you really check and see that nothing wrong, right, then just go ahead and use the quadratic formula, right? So the quadratic formula minus b. Okay, so b is now 3, plus minus square root b square minus 4ac over 2a. Okay, so minus 3 plus minus square root. Okay, so if you calculate inside, you will get 41 now. Okay, over 8. Okay, so y you will get two answers. One is the negative 1.175, or y equals to 0.4254, right? Okay, so don't worry that you have made a mistake, even if you think it's weird. Okay, for O level, just keep going and continue to solve the question as per normal. Okay, because even if you have made a mistake earlier on, right, you solve the question correctly, okay, using the appropriate methods for the rest of the question, you will still be able to get all the rest of the marks, all right? So don't just stop here because you think something weird and you have made a mistake or things like this. Okay, so cosine theta, okay, if you recall, the range for cosine theta is between negative 1 to 1. So this is outside the range for cosine theta, so you will not be able to get any solution from here. Okay, then from here, cosine theta is 0.4254. Okay, then if you do cosine inverse, okay, so since theta, if you look at the diagram, theta is the angle, the acute angle in the first quadrant. Okay, so you don't have to find basic angle, can just directly find theta. So you do cosine inverse, you'll get 1.13 radians. Okay, so this will be the value for theta. Right, but let's verify that this is a maximum value. So for this case, I think I would use the first derivative test. Okay, I don't want to go and differentiate dA d theta one more time. Okay, so let's use the first derivative test. Let's practice the first derivative test. Okay, so first derivative test, just draw a simple table like this. Okay, then divide it into 4 columns. Okay, so this is the value for theta, then dA d theta, and this is the graph, okay, the shape of the graph. Okay, so over here we have 1.13. Okay, and at 1.13, dA d theta is 0, right? Because it's the stationary point. Okay, so I'll just test one value slightly less than 1.13 and slightly more than 1.13. So you can actually just use the most direct value, 1.12 and 1.14. Okay, so if you try 1.12, you realize that you get dA d theta to be 13.3. Okay, which is a positive value, so it goes this way. If you put in 1.14, you get negative 9.9. Okay, so it's a negative value, so it goes this way. So you can see the shape. If you join up, okay, this way, you get a maximum point, right? Okay, so this will be a maximum point. So this means that when theta is 1.13, A will be a maximum, and hence the trough will hold the maximum amount of water. Okay, so we can just conclude from above. When theta equals to 1.13, A is maximum, and the trough holds the maximum amount of water. Alright, so this is actually a maxima minima problem. Okay. Okay, so I think overall it's not too difficult. Okay, it's not too difficult to differentiate the expression as well. But maybe the solving part you may need to take note of a bit lah, right? Okay, so I hope you are able to understand the solution for this question.